Welcome to a new test and teardown video. This time it's an HP electronic counter model 5245L. It's an 8-digit Nixie counter. Look at that, 8 of them. I just wanted to show you the start before I clean this unit up. As you can see here, it's super dirty, because I am of course going to see how much I can clean this up. Look at how dirty it is. Feet are removed, the 2 side handles are removed, and the top of the unit. Oy. I mean, I need to clean up and I need to open this before I power it up. There's no other way. Hopefully the next clip you're gonna see this nice and shiny. So I'm still in the progress of cleaning up. The fan filter is really not that dirty, so that is something of course I need to go and clean up. But to my big surprise, this one is with the very nice crystal oven reference. Hoppa, lucky. And the thing is, you can select to use internal or external reference. If you use external, in the old days, it wasn't really established yet that it was going to be a 10 megahertz reference. So a lot of equipment used all sorts of frequencies, including 1 megahertz. So that is what this is using if you want to use external only. So you can use internal, or you can also enable an output scaler. So that means this output is now an output, and it is of course at the same time running of the internal oscillator, right? But now you can of course select all the way up to 10 megahertz of output, 1 and 100 kilos and all the way. Isn't that just cute? 1 hertz or 0.1 hertz output. So that alone here is worth a lot to me, really, because I play quite a lot with frequency references and stuff. So now I feel like I really need to keep this one just because of the reference. So we're back after a little bit of cleaning. Let's see how that looks. They did scrape away some sort of an identification label that was here. Yeah, I think we can see the Nixie tubes now, and everything here is nice and shiny. There was a really ugly sticker right here, and I'm like almost happy about it right there. It was very yellow and gross around the switches. I guess you use those switches here the most, right? Oh, we also got a hole here. So yeah, I believe we're ready to power it up. There's just one little thing that annoys me a little bit. I know when you go like this and then tighten up, see, then this module is not loose anymore. And all you have to do is like this. You can hear the module should be loose and should be ready to pull up. It's not coming. So why is that not happening? There's not supposed to be any hidden screws and stuff like that. You're supposed to be able to change those from the front. So why is that not happening? Annoying. But other than that, we can have a little look and enjoy this beautiful piece of equipment. It is really full of all sorts of good stuff. It is packed with little electronic boards and extra transformers and God knows what. I believe that's actually filters for the power supplies, right? Yeah, the big heavy transformer is on the other side, and that will be sensitivity. Okay, speed up capacitors around. I mean, how fast should this be able to count? I haven't even looked up the specifications yet, so I better go and do that in a minute. AC and DC input. So now I am ready to do the first power up. Let's apply mains and then, oh, 3 watts. I didn't even turn it on. So why is this thing using 3 watts? Is it because of the crystal oscillator oven here? Maybe this oscillator is running, or it's trying to heat it up or something like that. But I think that kind of power should be a lot more than 3. But yeah, there is a power consumption of 3 watts. So let's... Oi, 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 oi. 80 watts. Oh no. So we got 2 defective. I hope it's only the Nixies. I see a little bit of blinkety bling in here. Oh man, there's a storm from that fan directly in my face. It's like being on a ship or something. Oh my god. Okay. Gate. We are in, okay, frequency counter mode. 1 second. Why isn't it? Okay. You should blink every second, right? Wow, haha, that has something to do with sample rate, right? So if I go this... Okay. Fantastic. It's not completely dead. I mean, let's try and input some signal, right? So, the unit is definitely alive. I input 123 kilohertz, and I believe what we see here is 122.99. That digit here is sometimes showing a slight 9, but I think this is a cathode poisoning problem with the Nixie tubes, and sometimes they actually recover if we wait long enough. So, I mean, I think the counter section is working. We just don't get any readout of the first and the third digit, and could also try and add a little bit more counting time. So 10 seconds of counting time, that should move all the numbers 1 position to the left, exactly as we see here, right? But then there is a missing dot. So we also got some neon bulbs that's not working. Of course I need to write down exactly what I find, what is working and what is not working. That is not good. So there's probably a... Yes, that was better. Good boy. Probably some noise in the contacts here and stuff like that. But I mean, it's definitely alive. So I'm quite happy so far. All I need to do is now fix this. And let's get back and play with the plugin module. Meanwhile, I can just show you a little bit of details. Maybe we should turn this off while we talk, because it's really, really loud, this fan. This is a 50 megahertz counter. So that means, of course, the first counter here can do 50 megahertz. So as you see here, they are different type numbers, and the PCB also look very different. I don't understand why they didn't make all of them the same way, but maybe those very fast transistors here, they use more power, they're more expensive, or something like that. Maybe we just see a little bit more transistors, I don't know really. But at least the 604 here is a 50 megahertz capable. So, and then the 644 modules, they're a little bit slower. And funny enough, they contain quite a lot of transistors and stuff. and then the rest, the 415, they're just slower, really, and then they look exactly the same. All this stuff here, it looks a little bit like it's the same 4-bit counters, and that is of course also what it is. And this is the time base dividers. And yeah, all this you see in here is of course the crystal oscillator. Yeah, power supply modules. Don't touch any of that because this thing runs off high voltages. Well, for Nixies it's not that high, but it is enough to tickle your fingers a little bit. So just don't poke around with your fingers. Yeah, and actually quite a lot of the PCBs here, you shouldn't touch anything. You never know unless you check it out. Data sheets and manuals that are like really easy to find. Let's just play a little bit more, right? I'm just testing maximum frequency, and this is 70 megahertz. Let's just go down to 60. Yeah, that is better. The reason why you see 2 here is actually because I'm inputting 2300. Oh, you see the Nixie here is starting to get alive. Goody. Okay, so that was 60, and the specified 50 is here. And so that Nixie also needs replacement. Or we just leave it like this for an hour and see if it's coming back to life. Also, I could measure the anode supply for all the Nixies and see if it's a little bit on the low side, because that is a classic problem. Then you start to see these non-covered cathodes. Oh, by the way, if you want to know how to pull up the Nixie modules, it is really hard, especially the first time, especially if you don't know how to do it. Of course, you take the PCB and wiggle it carefully up here, but you also stick in a screwdriver into the screw and use something else like this solid piece here as a crowbar, and then you just stick in some more stuff here, and then you can get up. Because if you try and grab the plastic here, it's bakelite, by the way, and it's gonna crack. It's real fragile and brittle and all that kind of stuff. So please don't break that, okay? And don't bend the PCB too much and be too angry about it. It just takes a lot of time. When the first is up, then there's a little bit more space for the others, and then it's going to be a lot easier. So here is my first Nixie module. I'm not going super detailed about how this works, the LDRs and the photoresistor driving and the neon bolts and all that in here, because I already published a HP counter, Nixie counter, and I went all the way to the super detailed level about this. So if you really want to know about that instead of this particular unit, I will put a link to that video in the description, so you can save your time searching around for that. To show you how easy this is, I took out the second one, and we know that one was working, remember? And the first one here was not counting. So that one is the first one, this is the second one. So, a neon tube tester, just see, there is gas in the tube. But if I take another one that is okay, look how bright and shiny that is. Super nice, right? So this tube here is just dead. It's that easy. Ha, lucky. The fun thing is that the type number is not the year 1970, right? Because this is tested August 68. So I mean, they don't have a time machine, right? So this unit is definitely from 1968. So that was the dead one. And I just went to my little Nixie storage. And I believe this is the part number, isn't it? Lucky me. Or is this luck? Or is it something higher than luck? To find this little box here. I don't know. I got quite a lot of Nixies in all sorts of sizes and shapes. And 2 brand new ones. Oh, what a great day. So that is pretty good, isn't it? I think we're back. I'm not sure. Yes, it is indeed counting. And that is one of the new tubes, and it's not fully covered yet. So that is just because it's, haven't been used for 50 years. So all we have to do is just wait and wait and wait, and then it's gonna get full coverage. So I'm not gonna bore you with that, but I think definitely that was a great success. Changing a few of their Nixie tubes. I also want to experiment a little bit with the time base and see how accurate it is. And yeah. I'm just having so much fun with all the features and function of this unit. So of course, everything seems to be working here with start and stop and the period kind of times. Oh, look at that! And here it is again. Look at the decimal point. And then here, oops, missing, and then it comes again. So yeah, definitely I need to change this neon bulb or a driver or something like that, right? So how is this working? This is something I need to figure out. Remote or time internal, period, average, function thingy, start, stop. I want to measure the time between start and stop, right? So how do I enable this feature? Oh, do I really need to read the manual? So it's actually quite easy. All you have to do is read the front plate, goddammit. Plug in, yeah. And then remote or time interval, I guess. Or time internal, something with this one, right? So this is now the time base that we are counting between start and stop signals. And I got at the moment, where's that one? Here is my stop is 10 Hertz and my start is 100 Hertz. So I'm just starting, right? And then I'm counting the time from a start to a stop. And then it works quite like that. So if I change my start frequency to 101 Hertz, see? It takes less time to count until the stop. Like that is a 102 Hertz. So I mean, it actually really works with all this time interval and good things. After a lot of patience and a lot of violence and all that kind of bad things, I managed to get the damn plugin module out. Oh my god, what a fight. And there's plenty of space to build all sorts of cool things into a plugin module. And this one is super simple. Obviously, it's just triggering on some variable levels and a little bit of attenuation and stuff like that, slope and AC/DC and things. So it's super simple stuff. So yeah, that's kind of what there is to it. Oh, some really cute dual fets and stuff, right? Oh, there's actually a funny thing here. So it accepts plug-in modules up to 5265, right? So that means not 67. That is more than 65. That's funny, isn't it? Actually, one thing I forgot to show you guys, and that is this frequency counter here works perfectly fine without the plug-in module mounted when you want to use it just in frequency mode or any other modes than plug-in mode, actually. And this is a little bit different from a lot of other HP counters. They kind of don't work without the plug-in module mounted. But there's another thing you need to know. In here is where you access the alignment of the oscillator. So of course you need to be able to measure the frequencies, right, when this is open. So that is probably why it's made like that. So now we'll play a little bit with alignment. So it's been driving me absolutely nuts about alignment of the oscillator. And here is a little bit about how it works. The oscillator itself is actually a 1 megahertz crystal oscillator, and this is all the oscillator drive circuits. There's actually only a crystal in here, a heater, and a temperature sensor. So that's all there is in this big box here. So this is a capacitor 4, and this is for the high voltage used for the heater. And the funny thing is, so the 1 megahertz from the oscillator goes to a multiplier. So this is the multiplier board that makes 10 megahertz out of it. It's a doubler and times 5 and all that anyway. But so the problem with this unit is, if I turn it on again, is it is just way off. No matter what I do, see, this is 50 megahertz and it's just very low, and I've been trying to trim everything. This is as high as I can get it, or I mean this is as slow as I can get the clock, so it will read more here on the display, right? And the funny thing is, it is exactly like this no matter how long I wait, and this is not how it is normally. Normally it takes some time, and then you see the value just go and go and go, and then it's super nice and accurate and stable. It's because there is a heat up inside this the crystal oscillator, and that is not the case here. The heater is not working, so it is not going to the correct frequency. So here on the bottom part of the oscillator, right up here, is this the big oven unit you just saw before, and here is the bottom side of C4. There is a little transistor down here. This is the transistor that is controlling the heater. And there's 40 volts across this transistor and no drive signal to that transistor. This is the rectifier used to create the 40 volts. And here is the A25 oven controller heater board. And there is a fault on this board, or maybe it is the temperature sensor. That is of course also a possibility. So now I need to look at the schematic and see if I can figure out where is the problem. Oh my god, I just went all the way with the oven controller. So this is the A25 oven controller board. I just unscrewed it here so I can see what I'm doing. And here is the schematic. I reassembled the schematic from 2 pages in the PDF, so it's easier for me to figure out what is going on here. And then it's just a measure around here, and quite easily I see that my minus 35 volt is actually minus 40, so that means there is no current usage, no heating. I kind of knew that, so it's not a big surprise to see that voltage a little bit too high. The oscillator and the amplifier for the oscillator, that's actually working quite good. So it's 1.5 kilohertz. It's running at, I think. But then it goes to this transistor, and then there was nothing. So that transistor is actually shorted, 0 volts on both sides, and there's actually also 0 ohms here. And so to be very sure, I lifted up the other transistor here. In the beginning, I was a little bit misled by the fact that this transistor here, that is the power transistor for the oven. I also saw 0 volts here, and that one is actually mounted on a piece of metal. I don't know if we can see that easily, but yeah, yes we can. It's right here, right under the red tip here. That transistor here is mounted on the metal. So I had the idea, oh, okay, that's probably a mechanical issue. The base of that transistor, that is the white and blue, white and green it is. I lifted that one, and oops, no short. But then, of course, the short just continues here. So now I think I can fix this real easy and get the oven up and running. So now I believe I repaired the heater regulator. I just powered this unit up, and we're now going to see if this value is going up. Obviously my reference signal here has been running the whole day, so that's completely stable and absolutely accurate. So we are going to see if this is going any better anytime soon. Now we'll go and measure the voltages and see if that is all right. I am still in the warm up, but look at that. Now I got -4.5 here, so it's totally warming up, and this transistor here is fully on, and that means all the voltage for the heater is now over the heater. My 40 volts is now down to 31, and that means 9 watts is dissipated into the heater. It also means the frequency is getting better and better all the time. It is not yet stabilized when it comes to temperature, so we're going to see this number rise a little bit more until we have a perfect regulation with the heater and all that kind of stuff. I think I can just easily measure the voltage on that point, and when that goes down to -21, then everything here should be in perfect regulation. At least this is what I expect to see. We are not there yet, and that is why I have to wait a little bit more. It is taking more than an hour for this thing to stabilize, and I think I have reached the point where it is as accurate as I can make it. So I think I will call it a day. Thank you for watching. See ya. Bye.